Hello my dear Prep 1 students, hope you are all fine today. In today's lesson we are going to take lesson 2, which is non-negative integer powers. This lesson is the same as the first one, only we have one rule new. Before we go and start lesson 2, let's first remember the rules we used in lesson 1. We said before that if I have anything raised to the power of 0, this means that it's gonna give me 1, even if this number was a negative number. Still, if it's raised to the power of 0, it's equal to 1. We also said that, for example, if I have a over b all raised to the power of n, this means that I'm going to distribute the n on the numerator and on the denominator, and this is going to be equal to a to the power of n over b to the power of n. One of the other rules that we took was, if I have, for example, a negative number raised to power m, the first thing I do is I go and see the power. If the power is even, like 2, 4, 6, 8, and so on, so the negative number is going to be cancelled and I will have only a positive number. And if the power is odd, like 1, 3, 5, 7, 9, and so on, the negative is going to be as it is. So it's going to be negative a to the power of m. We also said that if I have a variable which has no power above it, this means that I have x to the power of 1. And also for numbers. For example, if I have 5, this means that 5 is to the power of 1, but I don't write the power when it is 1. Lesson number 2, we are going now to remember two rules that we have taken before in primary 6 and we are going to use. We said before that if I have a over b all raised to the power of n times a over b all raised to the power of m, now I have here the same base. A over b and a over b, they are both the same base because they are the same number. How can I find their multiplication? Simply, it's a over b to the power of n plus n. When multiplying like base, we add their powers or their indices. So for example, if I have 2 over 5 all raised to the power of 3 times 2 over 5 all raised to the power of 2. Again, I can see here that I have the same base. Both of them are 2 over 5. Here I have to the power of 3 and here I have to the power of 2. So to find the answer, I'm going to have 2 over 5 raised to the power of 3 plus 2. I add powers, which is going to be equal to 2 over 5 to the power of 5. Let's take here another example. I have negative half raised to the power of 4 times negative half raised to the power of 3. Again, I have here a negative number, so I'm going to look at the power. I have here an even power, so the negative is going to be cancelled. And I have here a negative number raised to an odd power, so the negative is going to go outside. I'm going to keep it as it is. So now I will have half raised to the power of 4 plus 3, which is negative half to the power of 7. The second rule we are going to take, and that we have taken before in primary 6, is for division. Again, if I have the same base, then I'm going to subtract powers. The most important thing is that I have the same base. So for example, if I have a over b all to the power of n divided by a over b all to the power of n, here I have the base is the same a over b. So to find the answer, I'm going to make a over b to the power of n minus m. When dividing like bases, we subtract their powers or their indices. Here I want to take your attention to something which is very important. For example, if I have here 2 over 5 to the power of 2 plus 2 over 5 to the power of 3, here I do not add powers. Why? Because I have here addition. I only add powers when I have multiplication. And the same goes also for subtraction. For example, if I have 2 over 5 raised to the power of 5 minus 2 over 5 raised to the power of 3, also I do not subtract. Why? I do not subtract the powers because here I have subtraction, and I only subtract powers when I have division. And also we must keep in mind, if for example I have 2 over 3 raised to the power of 2 times 3 over 2 raised to the power of 2. Here I have different bases. The bases, they are not the same. I have one of them 2 over 3 and the other is 3 over 2. So also here I do not add powers. Why? Because I have different bases. So again, I add powers if I have same bases and they are multiplied together. I subtract powers if I have same bases and they are divided together. But if I have unlike bases and they are not the same, like this example, so I do not add powers. The same goes also for division. And remember again, when I have an addition or subtraction, even if I have the same base, I do not add or subtract powers. Adding and subtracting powers only is for multiplication and division. The new rule that we're gonna take today is that, for example, if I have a over b to the power of n and it's all raised again to a power of m. Here I'm going to take the base, which is a over b, to the power of n times m. So if I have, for example, a over b to the power of 3 and all is raised to the power of 2. Here I have power of a power, so I'm gonna multiply them together. So I'm gonna have a over b to the power of 3 times 2, which is going to equal a over b to the power of 6. So now we are ready to go and solve examples on this lesson. Let's go and open our binders, page 5. Let's go now and start solving. Question number 1, calculate each of the following, then put the results in the simplest form. Number 1, I have 1 over 4 to the power of 2 times 1 over 4 to the power of 2. Since I have multiplication, I go and look for the base. My base here is the same, 1 over 4 and 1 over 4. And I have multiplication. So when I am multiplying like bases or same bases, I go and add powers. So I'm going to have 1 over 4 to the power of 2 plus 2, which is equal to 1 over 4 to the power of 4. Again, here now I'm going to distribute the 4 on the numerator and on the denominator. So I have 1 to the power of 4 over 4 to the power of 4, which at the end is going to equal to 1 over 256. The question that I'm not going to solve now as classwork, they're going to be solved as homework. So number 2 and number 3, they're going to be homework, and I'm going to now to solve number 4. Negative 3 over 5 all raised to the power of 7 divided by 3 over 5 to the power of 5. Again, here I have the same base. I have a negative number raised to an odd power, so the negative is going to go outside. Same base, and I'm dividing, so I'm going to subtract powers. This is going to equal to negative, because we said the negative is going to go outside since I have an odd power. Negative 3 over 5 to the power of 7 minus 5. This is going to equal negative 3 over 5 to the power of 2, which is going at the end to equal negative 9 over 25. See how it's so easy? And now we're gonna go for number 5. 4 over 5 all raised to the power of 8 divided by 4 over 5 all raised to the power of 6 times 4 over 5. By looking here, we have the same base in the 3 of them. So I will have the base as 4 over 5. What about the power? I have here 8. And since I have here division, so I'm going to make minus 6. And since I have here multiplication, so I'm going to make plus 1. Because we know that any number which doesn't have power, this means it's raised to the power of 1. So again, I have same base. So my base is 4 over 5. 8, and I'm going to divide. So 8 minus 6, and then I'm going to multiply, so plus 1. And this is going to equal to 4 over 5 to the power of 1, and I don't write the power when it is 1, so it's only 4 over 5. Number 8, x to the power of 4 times y to the power of 3 times x to the power of 5 divided by x to the power of 6 times y to the power of 2. By looking here, I will see that I have two variables or two bases. I am going to apply the same rule on each base. So let's begin with x. Here I'm going to have x to the power of 4, and I'm going to multiply, so plus 5. Then I'm going to divide, so minus 6. And for the y, I have here y to the power of 3, and I'm going to divide it by y to the power of 2, so I'm going to make the power minus 2 since I'm dividing. And at the end, this is going to equal to x to the power of 3y. Can you find it easy? Okay, so let's go now for number 10. A to the power of 3, b to the power of 2 over c to the power of 3 all raised to the power of 3. Again, we said if I have a number raised to a power all raised to another power, a power of a power, this means I'm going to multiply them together. So I will have a to the power of m times n. I'm going to do the same here at question number 10. I have a to the power of 3 and it's raised also to the power of 3. So I will have a to the power of 3 times 3, b to the power of 2 times 3 over c to the power of 3 times 3. A to the power of 3 times 3, this is equals to a to the power of 9. B to the power of 2 times 3, this is equals to b to the power of 6 over c to the power of 3 times 3, which is c to the power of 9. Can you see how much it's easy? We just need to know the rules and apply it. And let's go now for page 7. We are going to answer now question number 14. Again, I have 2 over 7 to the power of 2 all raised to the power of 3. We said that power of a power, I go and multiply them. So I will have here 2 over 7 all raised to the power of 2 times 3, and it is times 7 over 2 raised to the power of 6. This is going to equal 2 over 7 raised to the power of 6 times 7 over 2 raised to the power of 6. By having a closer look here, I will see that the two numbers, they are the multiplicative inverse of each other. So simply, my answer is going to be 1. Because I know that any number multiplied by its multiplicative inverse, the answer is going to be 1. And let's go now for number 16. X to the power of 3 over y to the power of 2 all raised to the power of 16 divided by x to the power of 2 over y to the power of 2 all raised to the power of 16. Again, I have a power raised to a power, so I'm going to multiply them. So now I will have x to the power of 3 times 16 over y to the power of 2 times 16 and divided by x to the power of 2 times 16 over y to the power of 2 times 16. I'm going to have at the end x to the power of 48 over y to the power of 32 divided by x to the power of 32 divided by y to the power of 32. Keep in mind that here I have division between two fractions, and we know from previously that if I have division between two fractions, I leave the first fraction as it is, change the division to be multiplication, and flip the second fraction. So it's going to be 9y to the power of 32 over x to the power of 32. Great. Now I have x as a common base in both of them. So I will have x to the power of 48, and I'm going to divide it by x to the power of 32. So x to the power of 48 minus 32. And for the y, I have y to the power of 32 minus 32. So at the end, I will have x to the power of 16. Hope it's clear now, prep 1. And let's go together to page number 7. Question number 4. We are going to solve number 5, number 6, and number 7, and the rest is homework as well. So I would like to have your attention here. I have 3 raised to the power of 2 and this power of 2 is raised to the power of 3. So this means that the power of 2 is repeated for 3 times. As if I'm saying I have 3 to the power of 2 times 2 times 2. So this is going to equal to 3 to the power of 8. Again, here I'm not going to multiply the 2 with the 3. Why? The only case I'm going to multiply in the 2 with the 3, if for example, if I have 3 to the power of 2, all the number raised to the power of 3. In this case, I have power of a power, so I'm going to multiply them. But here, the only power, الباور موجود على الباور اللي اسمه 2. It's not on the same number. So this means that the 2 here in the power is repeated for 3 times. Did you get the point? So here it's as if I'm making 3 to the power of 2 times 2 times 2, which is going to equal to 3 to the power of 8. Here in question number 6, we want to make a small change. It's 5 to the power of 2, all raised to the power of 3. So this is the right question. Here I have the whole number raised to a power. So I have here power and power. I'm going to multiply them together. So my answer is going to be 5 to the power of 6, which is number A. And of course here, in number 5, my answer is number C. Let's go now for number 7. 3 to the power of 10 plus 3 to the power of 10 plus 3 to the power of 10. As we can see here, we said before that repeated addition is multiplication. So here I have 3 to the power of 10 is repeated for how many times? It's repeated for 3 times. So as if I'm making 3 to the power of 10 times 3, I have same base, so it's going to be 3 to the power of 10 plus 1, which is equal to 3 to the power of 11. So again, here I have the base as 3, and it is repeated, the same base for 3 times. So I can apply the rule that I'm going to take the power and add to it 1, which is going to be 3 to the power of 11. And now let's go for page 9. We are going to answer question number 11 and 12. Again, I have here b to the power of 3 all to the power of 4. So I have a power and a power. I'm going to multiply them together. So this should give me b to the power of 12. Now I want b to the power of 12, and none of the choices is b to the power of 12. But by having a closer look, I will find here b to the power of 4 times b to the power of 4 times b to the power of 4. And this means that I have b to the power of 4 plus 4 plus 4, which is equals to b to the power of 12. So this is the correct answer. I want to have your attention here in number 12. The quarter of the number 4 to the power of 20. Quarter means that I'm making 1 over 4 times 4 to the power of 20. By other words, as if I'm making 4 to the power of 20 divided by 4. Having the same base as 4, so I'm going to make 4 to the power of 20 minus 1, which is going to equal to 4 to the power of 19. So my correct answer is 4 to the power of 19. Let's take another example here. For example, I want to find half of 2 to the power of 10. So here, as if I'm saying I want 2 to the power of 10 divided by 2. Having the same base of 2, so it is 2 to the power of 10 minus 1, which is equals to 2 to the power of 9. Did you get it now, Prep 1? Hope it's easy, and let's go now for question number 6. We are gonna solve in question number 6, number 1, and number 5. 7 over 9, all to the power of 3, all raised to the power of 4. Again, here I have a power of a power, so I'm gonna multiply them. So 7 is gonna be to the power of 12. As if I'm saying I have 7 over 9, all raised to the power of 12. So as we know, I'm going to distribute the 12 on the 7 and on the 9. This means that I'm gonna have 7 to the power of 12 over 9 to the power of 12. But here he didn't write 9, he wrote 3. We know that 3 is half of the 9. To find what is 3 to the power 2, I'm going to make 12 times 2, because I know that 9 is double the 3. So 12 times 2, so 3 is to the power of 24. And in number 5, I have here 4 to the power of 4 over 4 to the power of 3, plus 4 to the power of 3 over 4 to the power of 2, plus 4 to the power of 2 over 4, plus 4, this is equals to 2 to the power of what? So let's take each term and find the answer of it alone. I have 4 to the power of 4 over 4 to the power of 3, this is equals to 4 to the power of 4 minus 3, which is equals to 4. The second one, 4 to the power of 3 minus 2, and this is equals to 4 as well. 4 to the power of 2 over 4, this is equals to 4 to the power of 2 minus 1, which is 4 as well, plus 4. So this means that I have 4 times 4, which is equals to 4 to the power of 2. Great, but I don't want it in the form of 4. I want it in the form of 2. So again, I am going to do the same thing I did here in number 1. I know that 2 is half of the 4. So to find it, I am going to make the power here, which is 2, times 2. This is going to be equal to the power of 4. So 2 here is to the power of 4. By now we have finished today's session. It's so easy, just a little rules that we go and apply it. I would like to thank you all, Prep 1, and have a nice day.